Welcome everybody. So now on to what you need to know to get ready for polynomials. So I selected some questions, some processes that we're going to want to make sure we feel comfortable with before we get into the polynomials unit. So what I did was I did a couple problems for each one, and we'll go ahead and take a look at them right here. So we're going to review back the zero product property. We're going to cover again factoring. A lot of factoring. We're going to go back over doing some problems for the quadratic formula, how to multiply binomials, finding the x and the y intercepts, and factoring perfect square trinomials. And I believe that was it. Yeah. So this is just going to be, kind of a good review to really kind of get you ready as we get into polynomials. And if you notice, mostly what we're dealing with here is just going to be with quadratics. And obviously, once we, expand a little bit more into our polynomial unit, we are going to build off a lot of these same techniques just for higher order polynomials. But we want to make sure we understand and have a good foundation of the basics. So that's why I wanted to make this video and, have you complete this work prior to it. So let's go ahead and get started. The main thing is remember the zero product property. When we have a product set equal to zero, which all of these already are, then we know that one or more of those quantities has to equal to zero. So basically the zero product property, if you have A times B is equal to zero, then A must equal zero or B equals zero. So what's nice about this is, if we automatically identify that we have a product equal to zero, then we can set them both equal to zero to find our possible solutions. So in this one, basically we have the product here when we have the parentheses right next to each other. So I'm just going to set them both equal to each other. X minus 2 equals 0 and x plus 1 is equal to 0. Now I can just solve using my inverse operation. So, I'll do this one out here. Add 2, so therefore we have x is equal to 2, and then subtract 1, x is going to equal a positive 1. And therefore those are your negative 1. Now, therefore, those solutions both work as if you were to plug them back in, you would see that they both make, both these solutions make the quantity equal to 0. So therefore they satisfy the equation. Now, sometimes not everything's nice in parentheses. Notice here, though, we still have multiplication, negative 4x times 2x minus 3. So we're going to apply the same process. Equal to 0. And then remember, a 2x minus 3 is equal to 0. So now in this case, notice here to use my inverse operations by dividing by negative 4, it's not really going to be changing my answer because 0 divided by negative 4, it's just going to be equal to 0. So that's something important to notice, that if you have x, again with this multiple, the multiple out there is really not going to be affecting your answer at all. And then this one, you're just going to add a 3, and then we'll have 2x is equal to 3, and then you'll divide by 2. So then therefore, x is equal to 3/2. Now, the next one might look a little bit more complicated. One, I kind of flipped the 0 to the other side, as well as I use radicals. But again, just, follow the same process that we did. So we have two products. They're equal to 0. Doesn't matter where the 0 is. And so therefore, we're just going to set each quantity equal to 0. Now, hopefully you notice that these two quantities are exactly the same, except one's added, one's being subtracted. So in this case, to use my inverse operations, I would add, and in this one, I would subtract. So I'm just going to kind of simplify here my answer, and I'm just going to use a plus or minus 2 radical 3, just so I don't have to write them both. And you could also use set notation, to represent your solutions, which we will be practicing coming up. So that's the zero product property, and that's very important because in our next set, we're going to solve by factoring. So again, the process of factoring is to rewrite rewrite an expression as a product. And the reason why that's helpful is if we can rewrite it as a product and we can have it set equal to 0, at least in this case, we can solve using zero product property, and that's going to be our idea. So the word solve, notice that these are not set equal to 0. But that's exactly what we're going to want to do. Solving is basically finding the solutions for x that make the equation true when f of x is equal to 0. That is the intended purpose here to solve this equation. So what I'm simply going to do now is I am just going to replace these f of x here with 0. All right, and again, actually in fx, it could be also called, find the x-intercepts, would be another thing, or find the solutions, when f of x is equal to 0. So I didn't really elaborate more on this question. I also could have set them all equal to 0 and gone from there. Now, again, we're not going to spend a lot of time on the factoring, so I'm just going to kind of quickly run through what I am doing, at least in my head, and because obviously I'll have extra factoring practice here for you. So in this one, we notice it's a trinomial. So I'm looking for what two numbers multiply to give me -6, but then add to give me a -5. And immediately I know that since my middle term is negative, then the larger of my two products or my two factors need to be negative. So therefore I immediately think here, well, then I could do 3 and 2 work, but 3 and 2 won't have to be positive, won't have to be negative, and that would add up to -5. But -6 and or 6 and 1 multiply to give you -6, and they also have a difference of 5. Therefore, but the larger one, which would have to be an x here, so it'd have to be x minus 6 times x plus 1. And again, guys, you can just check your work here by just multiplying using, FOIL or distributive property. -6 times 1 is -6. That's a -6x, and that's a positive x, which gives you -5x when you combine like terms. But now I can just go ahead and use my zero product property, and hopefully I don't need to show my work here. You guys can just see that the solutions here are going to be x equals 6 and x equals -1. In this next case here, we're going to do the same thing. What two numbers multiply to give me 1, add to give me -2? I recognize that's going to be the same product here. That's actually going to give us a perfect square trinomial. Now, a perfect square trinomial is something interesting that we're going to talk further about in this chapter. For right now, you could solve by using the zero product property, or you could use the square root method. By using the zero product property, you see that it's the same solution, it's just repeated. And that's what we call a repeated zero. But we don't need to represent it repeated as far as the solution. We can just say, the solution is x equals 1. And in this case, I'm going to use set notation rather than saying x equals 1, just another notation. The next one here, before I go ahead and do my factoring, I notice that there is a common GCF, or greatest common factor, I can factor out. And by doing that, I recognize that by factoring out a 2, I have now created a difference of 2 squares, which is something we want you guys to remember to, anticipate, because obviously when we're getting into this chapter, we want to, make our life as easy as possible. So when we can recognize special factoring techniques, that's going to a lot of times help us do problems a little bit quicker. So I can see that I could factor this rather quickly. I'm very comfortable with my difference of 2 squares, or at least, I've seen so many of them. So I quickly factor this. Now, one of the big mistakes students will make when they're using the zero product property is they'll immediately want to do x is equal to 2. Well, that doesn't make any sense, because when x equals 2, that does not make this equation equal to 0. So what's happening here is this 2 is actually being divided out, kind of like this -4 got divided out. So this is not a solution. That just gets divided out, and it does not impact your solutions to this quadratic at all. So therefore, I can now just say, x is going to equal plus or minus 3. Okay, so that is something that is going to come up, and it's another big common mistake a lot of students will make. All right, so we got a lot more factoring to go, because hopefully you noticed a little bit of a theme here. Factoring is going to be pretty important in this chapter. Let's just go ahead and factor these. Again, I have another GCF. I'm going to rewrite f of x here as 0, because again, that is my intended operation. So I'm going to factor 2. There should be an x squared plus 8x plus 16. All right, again, I recognize this is a perfect square trinomial. This is a squared term, and the square root of 16 is 4, and the middle term is double that. And again, if this isn't something you recognize as well like I did, then don't worry. When we do a lot of factoring practice, that is something that, we are going to continually build up on those skills. But this is nice, because hopefully what you'll notice here is that it's just a repeated x plus 4 times x plus 4, which I could rewrite as x minus 1 squared. I could rewrite this as x plus 4 squared. I just decided in this case, to expand it out rather than writing the squared. But again, what you'll notice here is the 2 gets divided out, so that doesn't impact anything. And then again, you can write this as repeated if you want to. It's just more work, like x plus 4 equals 0 and x plus 4 equals 0. But again, rather than using set notation, we'll just use x is equal to -4. You don't write it twice. It's just a repeated 0, and something we'll talk more about. All right, in these next two equations here, I do have a coefficient of my x squared, or my quadratic term. Unfortunately, though, not like the question D where I was able to factor it out. For E and F, I am going to have to look into factoring using multiple different techniques. One would be like the AC technique. There's a lot of different ways to do it. But I'm just going to kind of work through this in my head and kind of talk my way through it, because at least in this curriculum, we want you to be comfortable with factoring these without having to spend too much time figuring them out. So I'll set this equal to 0, 2x squared minus 7x plus 3. All right, so I notice I have a trinomial, right? And I notice that all these trinomials got factored into, a product of two binomials, even if it was a binomial squared. So going back to understanding the distributive property, I know my first two terms are going to multiply to give me 2x. So I'm going to work with one is going to be 2x, and the other one is going to be an x. Now, I know the last two terms need to multiply to give me 3, and they need to add, or these middle terms, these two terms, need to add to give me a -7x. So automatically I'm thinking, well, if I did 2 times 3, right, then that would give me 6. And then if I did x times 1, that would give me 7 once I combine them. But again, they need to be negative. So I immediately see, well, what about if we did a -3 and a -1? And again, I know this looks a lot easier because I've been doing so many of these problems, but it really is something that you just take a little bit of practice on and it will pay off for you. But again, let's check our work. And again, a lot of times when you're also, one thing I also mentioned is just guess and check. Pick some numbers. Hopefully you understand by looking at this that your two numbers have to both be negative. And it's really a -1, -3, or a -3, -1. So you don't really have that many options here to choose from. But the reason why they had to be negative is because my middle term is negative. And therefore, -1 times -3 gives me a +3. When I combine these like terms here, that's going to give me a -7. Now I can just apply my zero product property. 2x minus 1 equals 0. And x minus 3 is equal to 0. Therefore, my solution set, I'm going to have two of them. So when I use my inverse operations, I would have 1/2 and I would have a +3. Let's go ahead and do the next one using the same kind of technique here. So I noticed, looks like everything's the same. However, now my middle term is positive, but my last term is negative. So when that is the case, typically, remember, if you're multiplying two products and it's going to be negative, that means one of them has to be positive, one of them has to be negative. And since my middle term is positive, that means the sum of my products needs to, the larger sum needs to be positive. So let's go ahead and work this, see if we can figure this one out. So this would be 2x, and this would be x. All right, so in this case, why don't I do, when I do this -1, and then this would be +3. So now in this case, this gives you 2x, that gives you -3. This gives me a 3x, and that gives me a -2x, which gives me a difference of a positive x. So this one is going to work. Now I'm just going to go ahead and get right into my solution set here. This would be a -3/2, and this would be a +1. And again, now I'm just shortening up my work here. I'm setting both of these equal to 0 and then using inverse operations to solve. So just kind of speeding up so we don't need to take too much time on it from there. All right, now everybody loves factoring, kind of, once you get used to it. But we recognize that in a lot of problems, not everything is factorable, meaning you can rewrite every expression as a product of two factors across real numbers or across integers. So therefore, the quadratic formula is something we often use to go ahead and solve. And again, if we're solving, we're looking in this case for like the x-intercepts of these quadratics. So therefore, solving basically is, we're looking for the x values that make the equation true when f of x is equal to 0. That is by intention here of these to solve. So I'm just going to replace f of x with 0. Now to remember, to go through the quadratic formula or to solve using quadratic formula, we got to know what the quadratic formula is. So let's just go and quickly review that. X equals opposite of b plus or minus the square root of b squared minus 4. Knew that was going to happen. 4 times a times c all over 2 times a. So it's important everything is divided by 2a. And it's also just really important to use your order of operations. That's where a lot of students will get mixed up in. Also remember, whatever this b squared minus 4 times a times c is what we call the discriminant. And if we can understand a lot of things about the discriminant if you remember from Algebra 2. So I'll just kind of talk about that as we get to it. But for the first problem, I'm just going to kind of go through identifying everything. If you're a little bit weak on the quadratic formula, my advice to you would be to label what is your a, what is your b, and what is your c. What this does is that just, allows you to like check your work real quick, not to go, I'm only going to do this for the first one, but I think it is helpful. And then now basically all we're doing is we're plugging these into the formula and then evaluating. So you can just do x is equal to, let's see, opposite of b. So that's going to be -1. Oops. Now, what I do like to do is I do always like to put everything in parentheses when I'm doing this. Therefore, I know it's the opposite of b, where b is -1. And therefore, plus or minus the square root of, oops, why am I writing b squared? Let's do -1 squared minus 4 times a times c. Now I'm going to make sure my goes over, and this is all over 2 times a. Now, some people might say, well, why are you plugging in the 1? It doesn't matter. And yes, I just want to make sure you guys can, for accountability purposes, you guys can see, or accounting purposes, you guys can see where everything is. So let's go ahead and simplify though. So opposite of -1 is going to be a positive 1. And then plus or minus -1 squared is a positive 1. Now these are sometimes tricky. Just go from left to right. -4 times 1 is -4 times -3 is going to be a positive 12. So it's going to be square root of 1 plus 12 all over 2. And then if we just simplify that under the radical, we would have 1 plus or minus the square root of 13 over 2. Now, depending on, the multiple choice, depending on your teacher, depending on how the question is asked, you might need to simplify this. You could also write this as, x equals 1/2 plus or minus the square root of 13 over 2. So you can distribute that to both of them. You could also write this in set notation. There's a lot of different ways to go about this. But therefore, there at least you guys can kind of see from there. All right, in question number B here, we notice the negative. Now, but we don't need to factor out this negative. We can just leave that negative because that's just telling us A is now -1. So, if we're not using factoring, we'll just leave it. Typically, when I try to factor something, I would get that out of the way. All right, but in this case, I'm actually going to identify the discriminant first. That is actually my preferred way because then that kind of tells me what I am looking for. So I am just going to do the square root, or actually, I'm just going to do the discriminant here. It is going to be b squared minus 4 times a times c, which is 5. So therefore, we get 9. That's going to be 4 plus 20, or sorry, 4, plus 20. Yep, 29. What am I looking at? Oh, okay. I guess I had to keep those out of it. Okay, so that's going to be my 29. And again, remember, that's what is under the radical. So if you're taking the square root of a number that is not squared, then we know we're just going to have irrational solutions, which was the case over here. I just didn't talk about the discriminant there. But we know now this is the discriminant. And so we're going to have 2 irrational solutions. And remember, if the number was a square number, that means you could take the square root of it, 2 integers, then you'd have 2 real rational solutions. If the discriminant was 0, you would have 1 real rational solution. And if that discriminant is negative, then you'd have no real solutions or 2 complex solutions. But again, that's just a quick little review from there. I just really want to practice you going through the quadratic formula here. So the opposite of b here is now going to be -3. Plus or minus, take the square root of my discriminant. I just like doing it this way just because I understand what the discriminant is and I can make sense of the answer. And then 2 times a, which is -2. And therefore I can just take kind of stock as far as what I'm looking for, what type of solution I have. And then if I wanted to, write this as a solution, I could just do, negative let's just do, yeah, negative 3 plus or minus the square root of 29 over negative 2. Okay, so you could just write it as a nice little solution set there as well. Okay, so on to number C here, or letter C. So again, just doing the same thing. I'm going to work on the discriminant. So we'll say the discriminant is going to equal b squared minus 4 times a times c. And here you can say d is going to equal to, that's going to be b squared, which is 16. And then negative 4 times negative 6 is a positive 24. And that's going to give me d equals 40. So now we know that that is not a square number, but it is something we're going to need to simplify, whereas these two solutions, I couldn't simplify that. So now we'll go ahead and work on, let's go and see here. That's what I wanted. So let's go ahead and we'll have x is equal to opposite of b, which is negative 4. Plus or minus, we can square root of 40 divided by 2 times a, which is 1. Now notice I can simplify that square root of 40. That's going to be square root of 4 times 10, so that would be 2 radical 10. So I'll just rewrite that in simplified form. So negative 4 plus or minus a 2 radical 10. If you're a little bit weak on your radicals, don't worry. We'll be practicing more of that as we come up. And therefore, this simplifies to negative 2 plus or minus the square root of 10. And then as the 2 got divided into there. And opposite of b. Oh, I did it again. Okay. And there you go. So that is now your solutions. You can see those two solutions. So we'll just actually write that in there a little bit one more time. X is equal to negative 2 plus or minus the square root of 10. All right, so now let's go and get on to multiplying the following binomials. So, a lot of times when we're doing multiplying, you could think of FOIL, you can think of distributive property, you can think of the box method. I think really just understanding the distributive property, understanding that when you have a product separated with addition or subtraction, you got to make sure every single term is multiplied by every term. So FOIL is great, but FOIL breaks down once a lot of times when we get into higher order or longer polynomials. And the box method is great as well, just to keep things organized. So I'll kind of work through, those two, but there's also some things that we need to kind of recognize here. So, in this case, you could use, think about just everything needs to be multiplied by itself. And so negative 3x times x is a negative 3x squared. Negative 3x times x, and then we could do negative 3x times 2, which is going to be a positive 6x. Then we could do 1 times x, which is a positive x, 1x, and then 1 times negative 2, which is a negative 2. Now we notice here, by multiplying it this way, we have our like terms in the middle, so we can just go ahead and combine those. So therefore we get a negative 3x squared plus 7x minus 2, okay? Now the next one, we could do the same thing, but hopefully you recognize this is a difference of 2 squares. So when we multiply our inner and our outer, obviously, we're going to get x squared, we're going to get a negative 16, but notice, I'll just multiply this out because after this, we really don't want to continue multiplying out when we see the difference of 2 squares. Because notice, now when we go to combine our like terms, we get a negative 4x and a positive 4x. So therefore, that quickly simplifies to an x squared minus 16, okay? So therefore, it's just easier a lot of times to recognize these. And again, this is a lot of stuff. You don't need to draw this out. It's just a quick little way for us to recognize this. For the multiplying the following binomials, now again, this is another difference of 2 squares. So therefore, I really recognize here, this is a more confusing one, right? Doesn't look as simple there, but really, all I need to do is multiply my first 2 terms and my last 2 terms. So let's just kind of quickly do this. 3x times 3x is going to be a 9x squared. And negative square root of 2 times positive square root of 2 is going to be a negative square root of 2 squared, which is just going to be a 2. All right. And we could also do the same thing here, even with imaginary numbers. Just remember that I squared is equal to a negative 1. So again, we're just going to multiply our first term and our last term. So x times x is x squared. Here we're going to have a negative 9 I squared. Well, remember that I squared is a negative 1. So therefore we get x squared plus 9. Okay, so that's very important, and just something we don't, hopefully you've already reviewed a little bit of your complex numbers, and because that's something, again, that we will investigate here with our polynomials. All right, the next process is making sure that we remember how to find the x and y intercepts. This is something that, we talk about a little bit with functions, and it's something that is going to keep on coming up over and over again. So we want to make sure that you understand, even for quadratics, we remember how to find the x and y intercepts no matter what the function is or what the polynomial is. If I want to find the x-intercepts, that's basically a lot of times also called the solutions of the function or the equation, we basically just replace x with 0. So the x-intercept is when y is equal to 0, and the y-intercept, I'll do this, x-intercept is when x is equal to 0, and the y-intercept is when y is equal to 0. So basically, all we're going to practice here is really just kind of using our inverse solving technique. I mean, the main thing we want to make sure we understand here is how to rewrite these equations and then basically solve using inverse operations, or possibly, from there. You can notice here we're using vertex form here. This one's not, but if I want to find the x-intercept, I'm sorry, x-intercept, what am I doing? The x-intercept is when I totally messed that up. X-intercept is when y is equal to 0. The y-intercept is when x is equal to 0. So if I want to find the x-intercept, I'm going to just replace y with 0. Now, I could solve this by factor, and I do notice that this is a difference of 2 squares. You could also just add the 4 and then take the square root. Just remember, though, there's 2 solutions here, and that's actually something really, really important. So we have x minus 2 times x plus 2. Or you could just say 4 is equal to x squared. But if you take the square root on both sides, remember you have to include plus or minus 2. So I don't care which one you'd use in this case, just make sure you understand that there are 2 solutions, positive 2 and negative 2. The next one here is y equals a negative x plus 2 squared plus 5. Oops, I'm sorry. Let's get to the y-intercept. I'm starting to get a little off track. Okay, so the y-intercept is rather easy in this case. I'm just going to plug a 0 for x, and you can see I get y is equal to negative 4. So if I wanted to kind of understand what this quadratic looked like, at least I would have 2 x-intercepts, 1 y-intercept. I could probably draw a good graph of this quadratic just with that information. For the next one, doesn't seem as straightforward as the last one. So if I want to find the x-intercept here, by plugging my y equal to 0, you notice that I have a lot of stuff to undo here. So we got to remember to use our reverse order of operations. So first thing I want to do is always undo addition and subtraction. So I'm going to subtract a 5 on both sides. There I have negative 5 equals a negative x plus 2 squared. Now I want to undo multiplication and division outside of my parentheses. So we're working outside in, right? It's the reverse order of operations. So I'm going to divide by negative 1. Then I get 5 is equal to x plus 2 squared. Now, before I can get inside the parentheses, I got to undo squaring. So I'm going to take the square root. And again, remember, just like in this case, when you're taking the square root, you have to include plus or minus. So it's going to be plus or minus the square root of 5 is equal to x plus 2. And then I will just subtract a 2 from both sides to give me x is equal to a negative 2 plus or minus. Typically, we like to write that in front of the radical, square root of 5. All right, and in the last one, let's go and find the y-intercept. Now the y-intercept, when we evaluate here, again, we were going to want to make sure we follow order of operations. So we have 0 plus 2 squared plus 5. So now we're evaluating, so we're going to want to follow the order of operations, meaning we're going to want to work from inside out. So now 0 plus 2 is 2. 2 squared is 4. So we have y equals negative 4 plus 5, because I'm taking that 4 and I'm going to multiply it. Actually, you know what? Let's just multiply. That's technically this negative is really a negative 1, right? This becomes 4 and then plus 5. Okay, so that becomes negative 4 plus 5, so therefore y is equal to 1. All right, and last but not least here, let's do this one. So the x-intercept, hopefully I'll try to fit this in. X-intercept is going to be y equals 0 minus 1 squared minus 4. In this case, that is not the x-intercept, that is the y-intercept. What is wrong with me? X-intercept. So x-intercept is when y is equal to 0. So 0 equals x minus 1 squared minus 4. All right, so let's just go ahead and work this out. Let's add the 4 to the other side. So we have a positive 4 is equal to x minus 1 squared. Let's square root. That's going to be plus or minus 2. X minus 1. And then let's add a 1 to the other side. So basically this is going to look like this. X is equal to 1 plus or minus 2. So 1 plus 2 is 3. 1 minus 2 is negative 1. Forget that little point there. So sometimes you'll have something where you can't actually combine them, and therefore you'll just want to go ahead and do that. All right, last but not least is the factoring the perfect square trinomials. Again, if you remember what we kind of covered this when we were solving by factoring, and perfect square trinomials is something that we want you to be able to recognize in this chapter for completing the square, and hopefully that didn't give you some bad vibes. But I think if you really recognize the perfect square trinomials, that's definitely going to help you with completing the square. So remember that perfect square trinomials are trinomials that can be factored into binomial squared. Basically, the same binomial multiplied by itself. So we know these are perfect square trinomials. So basically, we're looking for what is the same number that multiplies to give you 4, and then that adds to give you negative 4. So therefore, we can recognize this as to be x minus 2 times x minus 2. Now, typically, when we're writing these as binomial squared, we just write these as x minus 2 squared. All right, what same number multiplied is giving me 9 as it giving me 6? That's going to be x plus 3 times x plus 3, which is x plus 3 squared. And then we can just hopefully continue this, recognize, and notice that when the middle term is positive, your binomial is positive. When the middle term is negative, your binomial is going to be negative. So there you go, ladies and gentlemen. Just to kind of recap, we covered factoring perfect square trinomials. We covered how to identify the x and the y intercepts, as well as using inverse operations to solve. We covered multiplying or expanding binomials, how to use the quadratic formula to find the solutions to a quadratic, how to use factoring to find the solutions of a quadratic, and last but not least, how to apply the zero product property. So again, this is not an exhaustive list of everything you need to know for polynomials, but I do feel that if you feel like you have a good foundation for what we did with this worksheet, then you'll be a much better standing as we get into the unit on polynomials. So I wish you the best of luck, and let's go ahead and get started. Cheers.